Let's take a look at this example. First, we're supposed to find the current I1, 2, 3. This is the current which will go through this wire and also over here. Okay, so this is the current which basically will go through these three resistors. So in order to find this current, I'm going to find first total resistance for these three resistors. I'm supposed to say equivalent resistance for these three resistors. So I have R1, 2, 3 is equal 1 over R1 plus 1 over R2 plus 1 over R3. So I have R1, 2, 3 is equal 1 divided by, open parenthesis, 1 over 10k plus 1 divided by 15k plus 1 divided by 20k. So I have R1, 2, 3 is equal 1 divided by, open parenthesis, 1 divided by 10 exponent 3 plus 1 divided by 15 exponent 3 plus 1 divided by 20 exponent 3 is equal 4.61 kiloohms. 4.61 kiloohms. So the equivalent resistance for these three resistors is equal 4.61. We can redraw the circuit, and my circuit right now is going to look like this. I have voltage source, I have resistor R1, 2, 3, and I have these two resistors in parallel. This is R4 and this one is my R5, and this is my R6. Okay, so this is my circuit at this moment. So please notice that resistor R1, 2, 3 is connected directly to the voltage source. That's why I'm going to say that my I1, 2, 3, right? I'm going to calculate from Ohm's law. So I have voltage source divided by R1, 2, 3. Voltage source is equal to 32 volts over 4.61 kiloohms. So I1, 2, 3 is equal 32 divided by 4.61 exponent 3 equals 6.94 milliamps. Okay, so this is the current I1, 2, 3. Okay, so this is the current which will flow through this connection and this one. Next, we're supposed to find current which will go through resistor R4, current which will go through resistor R6. Okay, and later on we're going to find I total. So please notice that these two resistors are in parallel, right? So what I'm going to do, I'm going to simply find the total resistance of these two, okay, and total, or we can say equivalent resistance of all these three. So let's find R45 first. R45 is equal R4 times R5 over R4 plus R5. R4 is equal 4k times 8k over 4k plus 8k. This is equal 4 exponent 3 times 8 exponent 3 divided by open parenthesis 4 exponent 3 plus 8 exponent 3 close parenthesis. This is 2.67, we can say 2.67k. Okay, so this is the equivalent resistance for these two resistors. So you can redraw the circuit, and your circuit is going to look like this right now. We have voltage source, we have resistor R1, 2, 3, and I have resistor over here R4, 5, and this is my resistor R6. Now you can see very clear that these two resistors are in series. So I'm going to find R4, 5, 6. So I have R4, 5 plus R6. R4, 5 is equal to 2.67k, plus R6, which is equal to k. So I have R4, 5, 6 is equal 4.67 kiloohms. So now we can redraw the circuit again and take a look what we are going to have this time. So I have R1, 2, 3 is in parallel with resistor R4, 5, 6. So I can find the total resistance. Okay, so I have R total. We can find R total, right? So we have R total is equal R1, 2, 3 times R4, 5, 6 over R1, 2, 3 plus R4, 5, 6. So I have R1, 2, 3 is equal 4.61k times R4, 5, 6 is equal 4.67k over 4.61k plus 4.67k. So if R total is equal 4.61 exponent 3 times 4.67 exponent 3 divided by open parenthesis 4.61 exponent 3 plus 4.67 exponent 3 close parenthesis. This is equal 2.32 kiloohms. 2.32 kiloohms. Okay, so this is my total resistance. If I want to find the total current, I'm supposed to use Ohm's law. I total is equal voltage source over R total, where voltage source is equal 32 volts, R total, which is equal 2.32 kiloohms. I have 2.32 kiloohms. So I have 32 divided by 2.32 exponent 3. This is equal 13.79 milliamps. So my I total is equal 13.79 milliamps. Okay, so let's take a look what we found so far. We found I 1, 2, 3, and we found I total. Okay, so Now we can find V1. V1 is the voltage across resistor R1. Okay, and please notice that R1 is connected directly to the voltage source. Okay, see, this is connection, and this is another connection, right, which connects simply, they connect this resistor directly across voltage source. That's why V1 is equal voltage source. So I'm going to write this down, let's say over here, in order to save the space, that V1 is also equal to voltage source, and this is equal 32 volts. Okay, so this is my V1. Next, I'm supposed to find current which goes through resistor I4 and I6. I4 and I6. So please notice that the current which will go through these resistors, right, is going to split into two currents over here, and is going to get back together and will create I6. So what I'm going to do right now, I'm going to find the current I456. I456 is equal voltage source over R456, where voltage source is equal 32 volts over R456. We found over here R456 is equal 4.67 kilo ohms. 4.67 kilo ohms. And this is going to be also my I6. Okay, so this is 32 divided by 4.67 exponent 3 equals 6.85 milliamps. 6.85 milliamps. This is my I6. Next, I'm supposed to find I4 and I'm supposed to find V5. So what I'm going to do right now, I'm going to find the voltage across these two resistors first. Okay? Why? Because I have to find V5 and I'm supposed to find I4. So this voltage will help me to find I4 as well. So please notice that the equivalent resistance for these two resistors is my R45, and we found that R45 is equal to 2.67K. So if I'm going to multiply I456 by R45, I'm going to find the voltage across these two resistors. So simply write V4 is equal to V5, and this is equal V45, and this is nothing else as I456, I456, right, times the equivalent resistance of these two will give me voltage across these two resistors. So I have resistance R45 we found is equal 2.67 K. So this is equal I456 we found this is equal 6.85 exponent 3 negative times 2.67 exponent 3. Okay, this is equal 18.29 volts. 18.29 volts. This is the voltage across resistor 4 and voltage across resistor 5. So we found V5. Next we're supposed to find the current which goes through resistor R4. We're supposed to find I4. In order to find I4, I'm going to use voltage V4 and resistor R4 and plug them into the Ohm's law. So I4, okay, I4 is equal V4 over R4. This is 18.29 volts divided by R4, which is equal 4 kilo ohms. So I have 18.29 divided by 4 exponent 3. This is equal 4.57 milliamps. 4.57 milliamps. This is my current I4. Next, I'm supposed to find also power. We found I4. We're supposed to find power P4. I have voltage across this resistor and I have current across this resistor, so I can find P4. So if P4 is equal I4 times V4. I4 is equal 4.57 milliamps. 4.57 milliamps times V4, and V4 is equal 18.29 volts. This is equal 4.57 exponent 3 negative times 18.29 volts. So this is equal 83.58 milliwatts. So this is 83.58 milliwatts. Okay, so this is my power P4. Next we're supposed to find power at resistor R1. Okay, we're supposed to find P1. Please notice that the voltage across resistor R1 is equal voltage source, and we have given resistance, so we can find very easy power. So let me write this down over here. So if P1 is equal V1 square over R1. So V1 is equal 32 volts raised to the second power over R1, which is equal 10K. So P1 is equal 32 square divided by 10 exponent 3. This is equal 102.4 milliwatts. As you can see, we found all currents, all required currents and voltages and powers, so we can say that the problem is solved.